Okay, this is the solution to part question 3, part D, from the Cive1460 exam in June 2024. Okay, so we've got here a quite a common question. Slight tweak on this one. Let's just sketch out what we've got from the information. We've got 400mm diameter pipe. So we've got D1 400mm, and it turns upwards 65 degrees. So upwards, this is telling us we're going to have a body force acting down, and expands to 550mm, rising 7.75. So a sketch here. So it's going to go up, expand a little bit. Let's get it to look like it's expanding a bit more. Okay, so it's expanded a bit. D2 equals finally 50 minutes. Let's tidy it up. 550mm. So risen in height 0.75 meters. The flow in the pipe is 45 litres per second. Q equals 45 litres per second, and we'll write that in meters cubed straight away, 0.45 meters cubed per second. The volume of the bend, volume equals 200 litres, which equals 0.2 meters cubed. Now the last bit of information not highlighted is 1.6 bar at the outlet. So quite often we're given the inlet pressure, but this time we've got P2 is equal to 1.6 bar. Now we'll convert that to newtons per meter squared in a moment. Other information? No, I think we've got that all. Okay, I could actually sketch on the diagram that we've turned through an angle of 65 degrees. Okay, right, first things to do is do the fundamental calculations that we're going to use later and get the units right. So we have D1 equals 400 millimeters, which equals 0.4 meters. We're going to need the area, so A1 is pi D1 squared over 4. That works out at 0.1257 meters squared. I'm going to do all these calculations to 4 significant figures. You can use 3 significant figures, but keep it consistent. Significant figures. Q, we're going to need the velocity. Velocity U1 equals Q over A1, which equals, through that calculation, 0.3580 meters per second. We can do the calculations for exit. The exit area, 550 millimeters. The diameter is 550 millimeters, 0.55 meters. A2 is then pi D2 squared over 4, which works out to be 0.2376 meters squared. So just check it against the A1, it's a bit bigger, good. U2 is equal to Q over A2, which works out to be, so it should be a bit slower, 0.1894 meters per second. A bit slower, okay, good. Right, we've got all the fundamental information almost together. Right, we'll next calculate the total force in both the x and y directions. So Ftx, we use our formula that we've been derived in class, u2 cos theta minus u1, and this comes out to be quite a small number of minus 12.5 newtons. Fty rho q u2 sine theta minus 0. I always put the 0 in because it just reminds us we've got two elements. This comes out to be positive 7.723 newtons. Pressure force. Well, we have P2 is equal to 1.6 bar. Remember, 1.6 bar is 1.6 times 10 to the 5 newtons per meter squared. We can write it in full, newtons per meter squared, also pascals, but right. We then need to calculate the pressure force. Let's go on to the next page. So I'll just write pressure force again. P2 equals 160 newtons per meter squared. Now we haven't got P1, so we need P1. So we apply the Bernoulli equation, P1 over OG plus U1 squared over 2G plus Z1. So P2 over OG plus U2 squared over 2G plus Z2. We know that Z2 is higher than Z1, so by 0.75 meters, so Z1 minus Z2 minus Z1 is 1.75. So we're going to the unknown, the only unknown in this equation is P1. So we can rearrange this this equation quite simply. Let's just do that to get P1. P1 equal to rho g, put this all in brackets, P2 over rho g plus U2 squared minus U1 squared over 2G plus Z2 minus Z1. You can do that calculation, and to four significant figures we get P1 is 1673 newtons per meter squared. Okay, so it's quite similar to P1, P2. Right, we need to do the pressure force calculations in the x and y directions now. Fpx is equal to P1 A1 cos 0 minus P2, this is P, A2 cos theta. We do that, put the numbers into there, and we calculate this would be 3296 newtons. FPY P1A1 sine 0 minus P2A2 sine theta, and that comes out to be somewhat larger, but negative, so let's just correct that, minus 36020 newtons. Then we calculate the body force. Now, because we've got a volume of the, because the pipe is moving upwards, there's a volume of fluid that's weighing it down. So in the x direction, that's horizontally, FBx is equal to, the body force equal to 0. FBy is equal to minus rho g times the volume, which equals minus 1000 times 9.8 times, and the volume given was 0.2 meters cubed, so that comes out to be minus 1960 newtons. Now we can work out the resultant force. Well, Frx equals Ftx minus Fpx minus Fbx, and this all comes to minus 3308 newtons. Fry Fty minus Fpy minus Fby, which comes out to be positive 3799 newtons. We could draw our vector diagram here. So in the x direction we've got negative, and in the y direction, well, considerably larger. Let's get this looking about like similar size. So our resultant force, so Fry, Frx, Fr is in that direction. If we call that theta, we can work out Fr is equal to square root Frx squared plus Fry squared. This comes out to be 38130 newtons, and tan theta is equal to so this goes to theta equals minus 85 degrees. So the minus 85 is that minus 85. So that's not a very good diagram of that. Let me see. Let's carry on down here. Let's say 85. Okay, so the force on the this is the force on the water at this angle. Force on the band is in the opposite direction. Same magnitude. Okay.